In this assignment, you'll be reviewing how to use a table to demonstrate a proportional relationship. I'm going to walk through it with you for slides 1 and 2, and then you're going to do slides 3 and 4 independently. Notice that this table displays the relationship between quarters and dollars. We know that we have 4 quarters for every $1. That means that in order to find the number of dollars for any given number of quarters, we are multiplying quarters by 0.25 because 4 times 0.25 equals 1. In class, we've been talking about how if we have a relationship like 4 for every 1, we need to find the constant of proportionality, or what we're multiplying by across our table. If I know that 4 times something equals 1, I can divide my product, the answer, which is 1, divided by 4 to tell me my missing number. Now 1 divided by 4 equals 0.25, and that can also be represented as 1/4. We want to start moving to representing constants of proportionality as fractions because it's going to be a little bit more clear later on, and you'll see why in a few minutes. So I'm going to change my blank to 1/4 because I know that I can multiply the number of quarters I have times 1/4 to get the number of dollars. And that will always be true. 1 times 1/4 is equal to 1/4. Or in other words, that 1/4 is 1/4 of a dollar, which we know to be true because there are 4 quarters in a dollar. Now, if we're talking about $2.5, we know that some mystery number multiplied by 1/4 is equal to $2.50 or $2.50. Now, of course, we're using a fraction and a decimal together, but that's okay because whatever mystery number of quarters we have here multiplied by 1/4 is going to tell us how many dollars we have, 2.5. That means that 1/4 of this number is $2.50. Another way to think about it is that 2.5 times 4 will be equal to this number here in the ratio table. And of course, 2.5 times 4 is 10. We can also check our work. Let's think about it. If we have 10 in total, and I split my 10 into half, I end up with 2 groups of 5. And if I split my 5s in half into fourths, 1/4, 2/4, 3/4, 4/4, each of those fourths is 2.5, which just confirms the fact that 2.5 is 1/4 of 10. Now, for the last 2 rows in the table, I would like you to tell me how many dollars are there in, let me write it out for you. How many dollars are there in 20 quarters? And how many quarters are there in $10? Go ahead and pause this video. Make sure you're caught up with me on these notes, and then come back for the answers. Okay, so we know that we can multiply the number of quarters, 20, times 1/4. If we split up 20 into 4 groups, or 20 times 1/4, we end up with $5. Now, when we're thinking about $10, we know that we can multiply 10 times 4, which is equal to 40 quarters. Now, you might remember that a few lessons ago, we would have simply divided by 4 here instead of multiplying by 1/4. like this, 40 divided by 4. Dividing by 4 and multiplying by 1/4 are exactly the same thing. Think of it this way. 1 divided by 4 is simply equal to 1/4. But by using 1/4, we can more clearly see the relationship between moving from quarters to dollars, multiplying by 1/4, and moving from dollars to quarters. 1/4 and 4 are called reciprocals. This is review, but if you've been out, it's a helpful thing to go over. Reciprocals are when the numerator and denominator flip, meaning that for the whole number, which is the same thing as 4 over 1, has a reciprocal of 1 over 4. Let me write that out for you. 4 over 1 has a reciprocal of 1 over 4, and that's just because the numerator and the denominator flipped. In a ratio table, when we have two constants of proportionality, those two constants of proportionality are always reciprocals. In slide 2, you have the same exact table, but this time we're moving from dollars to quarters. So we know we can multiply how many dollars we have by 4 to tell us how many quarters we've got. Some number times 4 will be equal to 1, which means I can divide 1 by 4 to help me find the missing number in this sentence here. Well, 1 divided by 4 is, of course, 1/4, which means that for 1/4, I have 1/4 of a dollar. Now, this table is exactly the same thing that we saw on slide 1. The only difference is that dollars and quarters flipped. Notice that 4 is now clearly the constant of proportionality, whereas in the first table, we found 4 here as our secondary constant of proportionality after we'd started multiplying from left to right. But the relationship between slide 1 and slide 2 doesn't change. We still have 4/4 for every dollar. Go ahead and complete the table in 2. We know that we had our last two entries were 20 quarters and $10, so you can add that here. When you're finished, you're going to complete slides 3 and 4 independently. On slides 3 and 4, we see the relationship between centimeters and meters. Remember that there are 100 centimeters for every meter. Remember, this is a short video that you're able to pause or go back to at any time if you need to hear me explain these concepts. If you need help, make sure you send me an email.